So, welcome everyone. I'm Rita Riker, President of Focus Greater Syracuse, and very happy to have you here for our March Focus Forum. We host Focus Forums to educate the public on what's going on with important community issues. And we invite individuals in the community who are working on these key community issues to share their roles and views on a subject, as well as what they expect may occur in the future. As we approach spring and more outdoor activity, we have selected Lyme and Tick-Borne disease as our topic for today. We have two very knowledgeable individuals who will speak on the topic, and I will formally introduce them shortly. First, some reminders. As usual, we're scheduled for 1 hour and we're recording the session. Today's format includes presentations from our guests, followed by Q&A. Thank you for all the folks who have submitted questions ahead of time. Many of these I think will be covered in the presentations, but we'll also have time to ask others. If you want to submit additional questions, you can use the chat. Now, I'm very pleased to introduce our panelists. First up will be Royale Scuderi. Royale is Executive Director of the Central New York Lyme and Tick-Borne Disease Alliance. The mission of the Alliance is to combat tick-borne diseases by supporting research and promoting awareness and education. Royale brings more than 15 years of experience in senior strategic leadership roles in the Alliance, She works for the Alliance Board of Directors to achieve the mission of the organization. She's also a Lyme disease survivor and personally understands the complexities of tick-borne diseases and how they impact people's lives. Dr. Brian Leydet has spent over a decade studying ticks and their diseases. He is an assistant professor of epidemiology and disease ecology at SUNY ESF. Brian holds bachelor and master's degrees in public health and a doctorate from Louisiana State University School of Veterinary Medicine. He conducted postdoctoral work at the Trudeau Institute in the Adirondack Park. Brian heads the Leydet Lab at ESF, which combines extensive fieldwork and laboratory methods to understand the ecological drivers of tick-borne disease risk. I'm going to turn this over to Royale. Royale?
Thank you for having us, Rita, and thanks for the introduction. So just briefly, to let everyone know if you're not familiar with the Alliance and what we do. So, we are a collaborative of providers, scientists, community members who support research, drive education, and can promote awareness to combat tick-borne diseases. And we came to that because Lyme disease and tick-borne diseases in general are complex diseases. So the solution needs to be a complex, multi-pronged approach as well. And so we believe that we can best address this, especially in our communities, by bringing the stakeholders that are working on those solutions together and connecting the dots between the researchers, doctors, scientists that we have right here in Central New York. You know, we bring them all to the same table, and we get them talking, collaborating, and we think that together we can be a lot more effective than the sort of older traditional siloed approach. So our priority is education. We've been running a 2-year educational pilot. We are into year 3. We have just hired a full-time education coordinator who will be in the community. You will see her out and about shortly as the season gets underway. And we give presentations, we have handouts, we do awareness through social media, traditional media, and the sort. So I won't belabor that, but we're there. Anytime you can reach out, and we're happy to provide information in whatever way possible. So with that, I'll turn it over to Brian, who's going to do the meat of the presentation. He's our tick nerd guru, so we're going to let him do the talk.
Thank you, Royale. And Rita, thank you. And I thank Focus of Greater Syracuse for the opportunity to talk. And today it's going to be a dense conversation, but I've tried to tackle all the questions in the presentation. So we'll see how I do. I'm going to talk about Lyme and tick-borne diseases in Central New York. But before I start, I want to take you back a couple years. And if I were to approach this group in, let's say, January of 2020, which seems like ages ago, and say that in the coming months, we were going to see an epidemic across the United States, that diagnostic testing was going to be very problematic. In a relatively short period of time, over 500,000 people will become infected with this microbe. Many of those would become long haulers. The vaccine was going to take some time to develop, so prevention was key. Staying inside was going to keep you safe, and that the agent responsible for that disease was going to be around for a long time. You'd probably think I was talking about COVID, and it sounds like it, but today we're going to talk about Lyme disease, and all those things I just said is very true for the bacteria that causes Lyme disease, Borrelia burgdorferi. So first, let's talk about the tick. It's a tick-borne disease, and there's a lot of ticks out there that can bite humans. This is just a subset of ticks that bites humans on the East Coast. They all look different, but not all of them carry Lyme disease or can transmit Lyme disease. In New York, the two common ticks that you'll find are Ixodes scapularis, the black-legged tick, or the deer tick, seen here on the left of your screen, or the American dog tick. For sake of this talk, we're going to focus on the black-legged tick, the one that does transmit Lyme disease. Now, Lyme disease is a complex disease, as Royale said. It's a complex ecology. It takes a lot of experts together to kind of understand that. But it takes what I call a plethora to tango. It takes the tick, it takes the bacterium, and it takes the host. And the host can differ from small mammals to large mammals. We'll focus on each of these separately throughout this talk. So first, let's focus on the tick. This is the adult female black-legged tick or deer tick. The tick has multiple different life stages as it develops. The female lays eggs. The eggs hatch into larvae. Larvae are six-legged little bugs. They're actually not bugs. I tell people they're not insects. They're actually related to spiders. That's why the adult's female has 8 legs. Larvae have 6 legs, but once they molt into their nymphal stage, they grow another pair of legs. They turn into the nymph and then molt into the adult stage. Now, Jeopardy answer here. Before they're adults, there is no what we call sexual dimorphism, meaning you can't determine the sex, the biological sex of the tick. The larvae all look the same. The nymphs all look the same. When they become adults, you can see here the adult male looks very different from the adult female. Now, ticks are hematophagous, meaning they feed on blood, and they feed on blood between each of their free-living life stages. So this is a picture of a tick getting into a mouse, and it inserts its hypostome. It's like a needle into the host through this mechanism of almost cutting. It uses these parts called chelicerae, which are scissors, to cut the skin, and inserts this barbed-like needle, which actually have teeth sticking up like a fish barb that keeps it attached. Now, this blood feeding occurs. Sorry, my kid is working from home. Got kids in here. Blood feeding occurs between different life stages. So here I've inserted a mouse, a cute little cartoon mouse, to kind of show you this. Blood feeding occurs between the larval to the nymphal stage. That's how they molt. And then from the nymphal stage to the adult phase. So that's how they molt. Now, they take 2 blood meals in these stages. They don't feed anywhere in between. So they have really a finite amount of energy between these stages. Once they're out of blood, they're dead. Unlike mosquitoes, who can take multiple blood meals or even feed on sugar. Now, at the adult phase, only the adult female feeds of the black-legged tick, and that is to lay eggs, basically, and then hatch into larvae. When we look at the disease itself, basically what happens, and we talk about the disease, 2 different kind of phases. Let's say you have an adult female that's infected with Lyme disease, as depicted here by the thermometer. The adult female will feed on an animal and lay eggs. Now, those eggs will hatch into uninfected larvae. So the larvae aren't infected, which is great. The larvae feed on small mammals, and that's depicted by this mouse here with a thermometer. And if the mouse is infected, that's when the larvae can pick up the infection and molt into the nymphs. Now, the nymphs come out, they're infected, and they're ready to transmit. They can transmit disease to the next mouse, or if they feed on an uninfected animal, they still have the disease. So it's important. It's what we call transstadial transmission. An infected nymph will still be an infected adult, and that adult can transmit disease. Now, if we look at the disease in another way, adult female hatches uninfected larvae. If those uninfected larvae feed on a not infected mouse, they're not infected as nymphs. But then those nymphs can feed on an infected mouse and pick up the infection and become infected as adults. So it's really important. The host is really important here to carry that infection through. Now, the life cycle of the tick is very complex, over 2 years. And I'm not going to explain this, but what this shows, different kind of peaks and dips, is that throughout the year, different life stages of the tick are active. Whether it's the adults in the winter or the fall, whether it's the nymphs in the spring, they're going to become active soon, or the larvae in the summer. It takes time to get through this phase and feed on these animals. And you can see they develop from larvae to adults and fed adults throughout this cycle. Where do ticks live? I get this question a lot. Ticks live at a lot of places, but we're talking about the black-legged tick. And they really like forests, right? Deciduous forests with leaves that fall down and decay. Ticks are very prone to drying out. So they like this humid understory, decaying leaf matter. They actually live under that leaf matter, and they have a humid, warm environment to survive in. And then they come out of the leaf litter to then feed on hosts. Ticks, like I said earlier, can survive up to 2 years. So they have a very long life cycle, not unlike other insects like mosquitoes, which don't live that long. In the winter, I get the question, what happens to ticks in the winter? Well, they live in tick igloos, right? We have that snowpack, right? And underneath that snowpack is that little ice layer. You know, when you walk in the snow, it crunches down, that's you busting through that ice layer. And underneath the decaying leaf litter is that moist, humid environment. Ticks are hanging out there in the winter and they're just resting. They're almost hibernating, waiting for that snow to melt and then come out and find a host. It's what we call microclimates. It's very different than what we experience above the snowpack, right? We experience very cold. It's like, how can a tick survive this? Well, they don't survive this. They live under that snowpack. And when the snow starts to melt, they come out and they find their hosts. How do they find their hosts? Well, there are 2 different strategies. One is the ambush strategy. And this tick right here is crawling up grass, putting her arms out and waiting for a host to come by on the hook on the host and then feed on the host. The other strategy, this is the strategy employed by the black-legged tick. The other strategy is a hunter strategy. And this is when a tick, you can see this tick here, marked here in the white dot, is actually chasing their host down. This is the Lone Star tick, which has become endemic in downstate New York. They can run to 3 meters after their hosts and then attach to their hosts. What are they seeking? What are ticks seeking? Well, a couple different things. They're smelling certain odors and CO2, you know, our breath. They're smelling ammonia, butyric lactic acid, our muscles, our sweat. I put a picture of a dead deer here. They don't seek out dead animals, but there is a tick that actually, well, there is a tick that seeks out dead animals, and they go to this deer, not to feed on it because there's no, good blood, but waiting for scavengers to come by to attach to the scavengers, the coyotes, the foxes, the other organisms that are coming to eat on this deer. Ticks are looking for radiant heat, right? Warm-blooded animals. So they see a thermal image of a deer and they're like, hey, that's warm-blooded. Let's go feed on that. Vibrations. I couldn't find a good picture of a deer with vibrations, but elephants make vibrations. They feel these vibrations. Now, we don't have many elephants here in upstate New York, but importantly, elephants have their own tick. So this is an amblyoma species tick. That is the elephant tick. Many species have their own types of ticks. Some ticks actually respond to the sound of their host. So feeding cattle, the oscillation of the masseter muscles on this cow, or barking dogs, they'll seek out these. And then lastly, ticks emit cologne or pheromones, perfume. Here's an example of larvae, right? Ticks lay 3,000 to 10,000 eggs, and larvae exist in these clutches, we call them. And this is a larva aggregation, and the larvae emit this aggregating pheromone saying, hey, come hang out with me, let's all find a host together. So here's a bunch of larvae, probably 500 larvae on a twig waiting for a host to come by. Now, ticks feed on a whole different types of hosts, especially the black-legged ticks. Some ticks are very specific to hosts. The elephant tick is very specific to the elephant. But the black-legged tick is what we call a generalist feeder, a Catholic feeder. It feeds on all different types of hosts. We have fox, we have chipmunks. Here's a song sparrow with ticks just all over it. There's about 36 ticks on the song sparrow. And importantly, it's important, the different host communities can drive differences in disease. And I'll talk about that here shortly. Because of the wide variety of hosts the tick can feed on, not all hosts carry the bacterium. And here I have this graph down here. I've added this little rainbow here. And it's important to know, you don't need to know what these numbers mean. They're this relative reservoir competence number. But importantly, the red, high capacity to become infected with Lyme disease and transmit that infection to ticks. The green, less likely to be infected and transmit that infection to ticks. Now you see deer here and you're like, well, Dr. Leydet, deer are important for Lyme disease. Well, yeah, they are. They don't get Lyme disease, but the adult tick doesn't feed on small mammals. The adult tick needs larger animals to feed on. So they need those deer, those possum, those raccoons, those coyotes to feed, to lay the eggs, to then those eggs and larvae become infected and the transmission cycle goes on. Now, importantly, I have Lyme disease here and I have the tick, the bacteria, the host. I've left out one important player in this, and that is us. We're important here, right? Without us, there's no problem. There's no disease. Do we care that a mouse has Lyme disease in nature? We don't care about that. We care about it because it spills into our population and makes us sick. So where do we encounter ticks? Well, I tell people we encounter ticks where ticks are and where we are. And you're like, well, that's really basic, duh. Well, it is duh, right? When you're walking on a trail, most of us walk on the trail. We don't walk in the thorn bushes. Not to say there's no ticks in the thorn bushes. There are plenty of ticks in there, but you're not walking through that. You're on the trail and you're encountering those ticks next to the trail. Importantly, the majority of people are not walking on trails like this, right? The majority of people are enjoying their yard. And basically where we encounter ticks is at the edges of our yard in the forest. It's called an ecotone, where we have our yard transitions into a habitat where the tick can survive. 70% of New Yorkers encounter the ticks in their yard or the edge of their yard, basically where we are and where ticks are. So we'll talk about the transmission of the bacteria that causes Lyme disease. And I'm going to forewarn you here, I'm a terrible artist, and this is my rendition of tick transmission of Lyme disease. I've used this since my PhD. My 4-year-old did not draw this, although he could probably draw better than this. Here we have a tick. It has a stomach. This is the stomach here in brown. And in the stomach, it has these green bacteria. These are the spirochetes. Now, these gray things are not ears. Those are salivary glands. And this gray blob is a mouse. So just work with me here. Ticks feed on mice. They actually produce a pool of blood. Unlike a mosquito that feeds in your capillaries right directly into your veins and arteries, ticks produce a pool and they suck from this pool of blood. And when they start taking in blood, it gets into their stomach and the spirochetes or the bacteria in the stomach go, hey, things are changing. It's getting warmer. The pH is changing. Something's going on. Let's start increasing in numbers. So those spirochetes, those bacteria that cause Lyme disease, increase in numbers and they get out of the stomach. They get into the circulatory system of the tick. It's a very primitive circulatory system, not like we have, but they penetrate into this, what we call hemolymph. And then they go, where do we go next? Well, they have to get into the salivary glands. So some penetrate from the stomach to the hemolymph. Some get into the salivary glands, depicted here. And those that reach the salivary glands have a chance to be injected into the host. And that's depicted here. So there's a lot more bacteria in the tick. Very few get injected into the host. And this process takes time. Unlike a mosquito that feeds very quickly on humans, ticks can take anywhere between 3 to 7 days to take their blood meal. And importantly, this process of this transmission usually takes at least 24 hours. Ticks in the first 24 hours of feeding are really regulating their water and their salt so they don't blow up when they take this huge blood meal. So that's why identifying the tick early and taking it off is very important for prevention of transmission. Now, this is specific for Lyme disease. Other diseases can be transmitted much more quickly. What happens when the bacteria gets into the host, to the human? Here's a science article, but it's a great picture. I'm going to go through basically what happens. So the tick bites you, injects that bacteria. The bacteria spread out, potentially causing that rash we think about. Bacteria get into the bloodstream. They're only in the bloodstream for a very short period of time, and they get into specific tissues around the body, the heart, the joints, the brain. And they kind of hang out there and they can cause those severe problems. What are those problems? Well, clinical Lyme disease really starts early on. It's a flu-like illness. We often hear about this characteristic skin rash, the erythema migrans, or the bullseye rash, but it's not always a bullseye rash. Actually, more often than not, it's just this really weird looking rash. I tell people it could be blistering, it could be uniformly red, it could be not red, it could be like this blue pinkish color. Sometimes it is clearing. Importantly, erythema migrans stands for a red expanding rash. So how do you know if it's a red expanding rash? Well, I tell people, if you get bit by a tick and you notice a small red rash, take a Sharpie and draw a circle around the outer edges. If you wake up the next morning and the rash is bigger than your Sharpie circle, that's an expanding red rash, and that is an erythema migrans. I don't care if it's cleared in the middle, not cleared in the middle, if it's turned green, brown, whatever. Go to the doctors. Say, look at that Sharpie line, doc. I need some doxycycline. Treatment is really important early on. If the bacteria disseminate to your tissues, you can have really severe symptoms, including major joint arthritis, cardiac issues, third-degree heart block. If there's any nurses, doctors in the audience, third-degree heart block can be fatal. We do have young people basically dying from this condition. You could have neurological conditions like Bell's palsy, as kind of shown here, stroke-like symptoms, or meningitis, the inflammation of the meninges around your brain. Lastly, if not treated and picked up early, we talked about long haulers. You've heard about COVID long haulers. Well, Lyme long haulers have been around for a lot longer. And we do see that some individuals infected with Lyme disease, despite treatment, have symptoms that last for a period of time. Now, people call this post-treatment Lyme disease syndrome, chronic Lyme, persistent Lyme, whatever you want to call it. We know that 10 to 20% of all Lyme cases will have these symptoms. And these are diffuse symptoms like fatigue, joint pain, and they're true symptoms. What's causing it is highly debated, but we know people are still suffering. And they're suffering because diagnosis of the disease is very hard. Early disease especially is very hard to diagnose. It's usually based on clinical symptoms, if you have them, a history of a tick bite in an endemic area, so knowing you were potentially exposed to a tick, and then potentially serological testing, the diagnostic test, but this test is not very good. It's indirect, meaning it detects your body's response to the bacteria. It's not a direct, hey, the bacteria is there. It's, does your body respond with antibodies? And in early disease, because your body takes time to develop antibodies, it only detects between 9 to 40% of patients. 9% of patients, that's pretty low. So you're really counting on the doctor and you to be hyper aware to know, hey, I've got flu-like symptoms. It's summer. There's no rash, but I was out hiking at Green Lakes. I need doxycycline, right? Let's talk about the disease in general. There's about 460,000 cases of Lyme disease diagnosed every year. Last year, the year before, next year. That's a lot of people getting sick. So it's usually 13 states have 95% of all cases. So the Northeast, New York, hyper-endemic for Lyme disease. It's increasing. So this graph shows the number of estimated total diagnosed cases on top of the reported cases that are traditionally reported to the CDC. But it's a lot of people getting sick. And remember, 10 to 20% of them are going to have long-term symptoms. What really scares me is this graph, because I teach epidemiology, and epidemiology, I tell my students, look for patterns. That's what we do as epidemiologists. What sticks out to you on this graph? Well, what sticks out to me is there's two peaks. There's a peak here in people between 55 and 69, and that's scary, but there's a peak here between the 5 to 9 and 10 to 14. That's very scary. So these are the two groups of individuals that are suffering the most from contracting Lyme disease. Long haul Lyme disease may not be, if you're older, you live with Lyme disease for 5, 10, 15 years. But if you're 5 to 9, 10 to 14 and get Lyme disease and have to live with it for the rest of your life, that's a serious problem. Additionally, this is Lyme disease based on biological sex. And we see on the left more males than females, but we still see that double peak in those age groups. So it's still different ages, more males than females. Now, if we bring this is nationwide, we bring it closer to home. We look at Lyme disease in New York State, and I've basically divided the state out into regions. We can see our region number 4, Finger Lakes number 2, and then the graph of the rate of disease in those regions. And what you should see, again, looking at patterns, Lyme disease is increasing in a lot of regions. If I look at the percent change over the decade between 2008 and 2018, you can see that in Central New York and Finger Lakes, you're talking 500% increase in rates of disease, almost 1,000% in the Finger Lakes. Going down to Southeast New York, you're seeing actually decreases of Lyme disease. And that could be due to a couple different factors. The increase of a tick that doesn't cause Lyme disease, the Lone Star tick, and potentially the better practices, prevention practices in those regions because they've lived with Lyme disease longer. So this is a problem affecting our state and our region. Now, it's not just the clinical disease, it's not just the signs and symptoms that's the problem, but it's also the cost of the disease. So here I've shown you the cost of the disease. So this is acute Lyme disease. This is just going to the doctor, getting the doxycycline. It's estimated between $1.1 billion to $1.6 billion a year in healthcare costs for Lyme disease. Now, if we look at long haul disease, it's even more staggering. You're talking between 25 to $75 billion every year. And as more and more people get infected, this number is only going to rise. Now, I talk about Lyme disease and people always go, well, Dr. Leydet, Lyme disease is a rich white person disease. And it kind of is. It affects Caucasians more than it affects people of different color. It affects males, and it affects ages 5 to 9 and 55 to 69. Now, those are still disparities because they are affecting a group differently. But it's not just white Caucasians that are getting Lyme disease. Importantly, what we're seeing is that people that have delayed treatment are having more long-term symptoms. And delayed treatment is strictly associated with being uninsured. And what types of groups are uninsured? More often than not, right? So you have these individuals that are low socioeconomic status or at a disadvantage that are ultimately having more long-term symptoms. The other thing is people of colored skin. The red rash, it's great if you see that red rash, but people of darker skin as depicted here, this is an erythema migrans. I can't see it. I hope the doctor did to treat this individual, right? So individuals with darker skin are going to be less likely to get diagnosed based on that skin rash. So those manifestations do differ. And then there is evidence that some groups, some ethnicities like Hispanics actually suffer different types of symptoms and different times of the year than non-Hispanics. Lastly, the disease is not just a disease of the countryside, right? Well, you got to have woods. No, recent studies have shown that disease rates in urban areas like Pittsburgh, Pennsylvania, and New York City are just as high as the rural areas. People are going out and traveling to areas where ticks are, or ticks are infecting parks inside the city. So it's not just a disease of rural, it is a disease of the urban area as well. All right, it's not just Lyme disease either. There's been a lot of tick-borne diseases spread by all different types of ticks. And this is just the conglomeration of all the tick-borne diseases that have been discovered since the 1900s. And that's a lot of them. Importantly, in New York State, these are the diseases ticks can give you. And that's a list. More importantly, the tick we've talked about, the black-legged tick, can give you all these diseases. That's scary, right? This tick can transmit more than one disease. And we're seeing increases of these across the state, across the country. Why? Why are we seeing this increase? Well, a couple of different factors. These are the two major factors, I would say. One, on the left here, is the total deer population in the United States. And colonizers came to the United States and almost decimated deer, basically almost wiped out our deer population for eating. That's what we wanted to do. We realized as humans that was a bad thing, and we brought deer back. That in itself came with its own problems, and Lyme disease was one of those problems. On the right here, I show what European colonizers did to our forests. They cut down the forest. They basically massacred all the trees out there. 1600s, coming in 1910, we have lost a lot of forest. Now, we as humans realized that was wrong, and we have brought forests back. But bringing forests back has also led to increases in diseases associated with those places. Importantly, the forest we brought back was not this virgin forest, right? This great expanses. You don't see a lot of forests like this in the United States. You see these types of forests, and these are fragmented forests. And these fragmented forests are very different than virgin forests. And here's my example here. Here's a virgin forest on the left and a fragmented forest on the right. And what's the difference here? Well, what should stick out is that there's less edge on a virgin forest than there is in fragmented forests. And where do people get ticks? They get ticks where ticks are and people are. Fragmented forests lead to more people density and contact with areas where ticks live than the virgin forest. Not only do we have more contact with those ticks areas, but virgin forests have a very different ecosystem, have a very different host community structure. And we talked about host and their ability to carry the disease, right? This is a harmonious forest, right? You've got your mesocarnivores, you've got your top predators keeping into check the deer, you've got the bobcats keeping in check the little small mice. And we do find in continuous vast forest lands, we do see less disease because of this. In a fragmented area, you find a very different host community structure. These are the hosts that thrive around humans: deer, mice, coyotes. You have tons of mice. I mean, I'm cleaning out my shed right now and there's, mice nest in there, right? So these are the animals that are driving Lyme disease, and they're the ones that like to really live around us. Second, this map. So this, if you're a gardener, you should know what this map is. This is the map that says when to plant your plants and what plants you can grow. And we're thinking about plants right now. We're like going to get some tomatoes out. There's some carrots. These are your growing degree days or your zones, right? And what we're seeing with climate change is we're seeing changes in climate, in these zones, in the number of heating degree days. Now, it's important because remember, the tick is very complex. It's 2 years, right? It's got to go from larva, it's got to go all the way to this fed female. And most of this 2-year life cycle is off the host. It's in the environment, exposed to temperatures, to rain, to photoperiod, the light period, almost like a flower or a fruit, right? There's a reason we in upstate New York can't grow oranges, bananas, and coconuts. We don't have those growing degree days or heating degree days for that fruit to get from seed to producing a nice, juicy orange. Now, who knows what's going to happen with global climate change? We do know that global climate change is really affecting the ability for this tick to get through that growing cycle. And it's making more and more areas conducive for that tick development. Now, maybe we have oranges here next year in upstate New York, but I wouldn't hold my breath. All right, what can we do about this? There's some things we can do about this. Let's take it apart here and see where we can eliminate chains of transmission. What can we target? Well, let's target the tick. You may have heard of tick tubes. Tick tubes are this idea where you put out some a paper towel tube with some cotton, with some bug spray in it, and basically the mice comes, gets the cotton and makes a nice little den for their pups here, and there's no ticks. Oh, that's great. That's a great idea, right? Theoretically, it makes so much sense, except ticks use all different types of hosts. So if you only have mice in your yard, probably going to work if you do this enough. But ticks are very good feeding on birds, which don't use cotton, chipmunks, which don't use cotton, voles and shrews, which don't use cotton. So, you're taking out one part of the equation, but that's not the only player. What about deer, right? I said earlier, deer are important for the adult ticks. Well, people have tried, right? They use these 4-poster deer stations where the deer come in and they roll on these bug spray applicators, and it kills the adult ticks. It's been shown to work to a certain degree, but they're very, very expensive and cost prohibitive. So it's going to be very hard to treat a total environment for them. Spraying your yard, right? People ask me all the time, what should they be spraying in my yard? And spraying does work, right? There are some really good synthetic, what we call acaricides or insecticides that certainly kill ticks. However, they also kill other organisms, right? They're not specific to the tick. They'll kill your butterflies, they'll kill your mosquitoes, which is not a bad thing. Your ladybugs, that's not good, right? So many of these synthetic acaricides work really well. It's just they're very toxic to other organisms, off-target effects. They're toxic to the aquatic system. They also require licensed applicators. Some require specialized sprays, whether they're a high-pressure sprayer. There are other safer natural alternatives, but they don't work as well. They also degrade faster in the environment. That's why they're safer and all natural, right? So you have to have multiple applications throughout the year. And sometimes that's cost prohibitive for individuals. All right, so then like we're not going to get rid of the tick. What about the bacteria? There's some things on the verge We have on the left, we have an edible mouse Lyme vaccine. It's these little pellets that they encode with a vaccine, and they basically vaccinate the mice. But going back to this idea that mice are not the only host, this is only one part of the equation. The other thing that's being done in some areas on some proposed is the release of genetically modified mice that produce an antibody. They're talking about this on Martha's Vineyard and Nantucket Island, but releasing genetically modified organisms in the environment has its downsides, and people are not always okay with that. So be on the lookout for these types of things. It's also just the mice, right? What about the host? What can we do about maybe the host? Maybe we target the host, right? Not going to work with the mouse, not going to work with the tick, the bacteria. What about the host? Well, we try, right? Syracuse uses deer culling, not going to work. You need to get deer down to such the lowest level, basically 2 deer per square kilometer. I have more deer in my yard than could be 40 square kilometers, right? It's just, we're not going to rid the deer. We're not going to kill all the deer. Now, if we kill all the deer, we probably have a good control, but it's just not going to happen. There's just too many of them. All right, what about people? Let's get rid of people. People are the problem, right? We can't do that, but we can. We can do prevention through education, right? Prevention. If we prevent disease, we're taking people out of the equation. We're not worrying about the disease. So I always ask this: how many people brushed their teeth this morning? Raise your hand. Oh, great. You're preventing cavities. How many people go outside today? Maybe not today. Put sunscreen on, right? Great. You preventing skin cancer, sunburns. How many people get in a car and wear the seatbelt? Great. We're wearing our seatbelt. 30 years ago, 40 years ago, seatbelts, people didn't wear seatbelts. Now it's almost natural we wear a seatbelt, and that's to prevent us from dying in a car accident. Prevention works. And we need to think about Lyme disease as something like wearing a seatbelt, doing things that prevent us from getting sick. So what can we do? Wear proper clothing. When you go out to an area where ticks may be, you wear light colored clothes so you see the ticks on you because they're dark. You pick them off, throw them away. You tuck your pants into your socks because if ticks get underneath your clothes, you're not going to see them. It gives them time to attach. Ticks grab on to your lower extremities and they crawl up. When you find ticks on your hair, it's not because they jumped off a tree and flew. Remember, they're spiders, not insects, so they don't have wings. They climbed all the way up there. They've had all that time to climb up and attach behind your ear. Got to get them before they get there. Using personal caricides, using that bug spray. I recommend permethrin on your clothes. It's really good at killing these ticks. Now, this is only for your clothes. So you got to, really look how you read the instructions when you apply this, because it is toxic for cats right out of the bottle. Once it dries, it's not toxic anymore. Once it gets re-wet, it's not toxic. But this goes on your clothes, your shoes, your socks. And then for your skin, you can use a picaridin or DEET-based sprays to keep away ticks and mosquitoes. Importantly, EPA has find the right repellent for you. You can enter all your information and it'll say, this is the repellent you should use. When you get done, even if you've done all this, do your tick check. Get home, look for ticks. Remember, 24 hours, that's that special area of transmission for Lyme disease. Take that tick off. Placing your clothes in a hot dryer, it will kill ticks that haven't attached. Taking a shower after you're outside, right? You're gonna be sweaty anyways, take a shower. Look for ticks on you, take that tick off. What can you do around your home? Well, it's really separating your, basically making safe zones and keeping people away from the places where ticks are. So the edge of the forest. You can make like wood chip barriers that basically has this visual idea that say, kids, you stay away from the forest, you play in the sunny yard. Now, you can pick up ticks in the middle of your yard, but you're less likely to. So you do want to decrease the amount of deer that are attracted to your yard. Mice, you want to decrease the amount of mice that are there. But realistically, it's just keeping your kids away from that edge as much as possible, and then doing all those personal prevention measures to decrease disease transmission. You can still get bitten by a tick. Trust me, I've gotten bitten by ticks, and I do a lot of prevention. So what do you do if you do get bitten? Well, you take the tweezers and you grasp the tick right at the base of its head and the skin and just pull it straight out. Works every time. Don't burn it with a match. Don't put petroleum jelly. Don't do some voodoo magic and some, seance to get this thing out. Just pull it out. Take that tick and place it in a Ziploc bag and save it. Don't crush it. Don't throw it down, the stairs. Don't put it in your toilet. Keep it as evidence. There's a local lab at Upstate. My colleague, Dr. Saravan Thangamani, you can send the tick to get tested. And here's his lab website. You can look up got ticks, and he'll test it for the pathogens. You monitor yourself for tick-borne diseases. If you develop any type of symptoms after the tick bite, go to your doctor. Our website, cnylymealliance.org, has some really great information, as Royale mentioned earlier. And then for the clinicians out there, I'm not a clinician, but really importantly, recognition is key early to get that diagnosis. So that flu-like symptom in spring and summer, the been outside kind of thing, saving the tick, having that tick to show your doctor. Early antibiotics work very well for most tick-borne bacterial infections. Early antibiotics work very well. Early is the key here. For other viral or other diseases or late-stage manifestations, a lot of times it's just supportive care to try to deal with those symptoms that you're going to have for a while. And there is a vaccine in development right now, but it's greater than 5 years out. Upstate's likely going to be a phase 3 trial location, but there is hope. However, remember, it's not just Lyme disease. So there's other diseases, and Lyme disease is only one of them. So with that, I'll take some questions if there are still some left. This is me and my son collecting ticks in our backyard.
Great. Well, thank you, Brian and Royale. Thanks to you both for being here. We had a lot of questions come in from folks in advance. We don't have a whole ton of time, but if folks want to put them in the chat, we'll see if we can get to them. Brian, true to his word, did answer just about all those questions, but I do have a few. But Royale, I'll turn it to you first. Brian gave us a wealth of really valuable, interesting information, but curious about I'm a policy wonky sort of person. I dare say a fair few of our participants joining us here today are as well. What sort of work do you all do in terms of education and outreach and coordination? Curious to hear from you about some of the work of the Alliance.
So, well, we do a lot of our work is presentations like these to community groups, businesses. We're hoping to start doing more with schools, children. Last year we did a camp pilot program at 2 local YMCA camps where we educated and distributed tick kits that we put together for the children. So we're going to expand that this year to get to more children, because we recognize, as Brian pointed out, that that 5 to 14 age group is at extreme risk. And like Brian mentioned, I'm a Lyme long hauler, but that's one thing. If you get it when you're 10 and you're a long hauler, that's something totally different. So we're doing a lot of that. We do have handouts in English and Spanish. I did see someone had asked about Spanish. We do have handouts that are in Spanish that we can distribute. We have digital and hard copy. So we'll do both of those. I do lots of TV interviews, radio, getting the word out. We have an extensive social media campaign. We have a website. We do traditional media. We added billboards and transit signs last year, really trying to blanket the entire demographics of our neighboring counties, because they vary from an urban inner city like Syracuse population to a rural, Morrisville, Oswego County, Madison County. We have various populations and people who have differing access to internet resources, things like that. So we're on the ground, we're virtual, we're social media, we're traditional, we do have tangible handouts. So all of the above.
Gotcha. Well, thank you. We had a question just come up, I think sort of related in the chat there. Why do doctors sometimes fail to recognize this, right? And I guess I would put that back as a larger question. Do you feel like it's getting better, right? And not better, but improving in clinicians' analysis and awareness of it, in the work that you are doing and others, just from sadly, there being so many cases that there's a greater awareness for folks to do preventative measures, for medical professionals to treat it or even recognize it. I'll ask you both, I suppose. Does it feel like we're moving in the right direction at all, or is it still an uphill slog with much, much more to do?
I personally feel like it's still much of an uphill slog. I think we've seen some improvement in care as some doctors have come around and are educating themselves and learning more about this. And oftentimes I hear the patients are educating them. And then they come to us and say, hey, can I have your handouts? Because, my patient brought this in and, this is great information. So I feel like it's very slow, very uphill. That is how the medical system works in every aspect. It takes a long time for change. And we are tackling that as we're trying this year to work on some healthcare provider education, whether that's a CME program or even getting into medical schools, I think would be huge for the future. But it's an uphill battle. It's an entrenched sort of way of looking at disease, and these complex diseases just don't work the same way. You go in, you tell your doctor what's wrong, they hand you a prescription. This is more complex than that, and I think that that's a difficult paradigm shift.
You have to also remember, physicians don't just treat Lyme disease, right? They have to know so much about all different types of things. I sit there, live, eat, and breathe Lyme disease. Everything that comes out new, I'm on top of it. So it really takes education from the experts to then for those doctors to learn. And I'm a one-man band that teaches still in the classroom. So it'll take time because doctors are treating COVID now and those types of things.
Right. Brian, a question for you. We had a question in the chat. I saw a few come in earlier in the questions we received in advance about pets. Are there tips, suggestions for folks who dogs and cats, other maybe pets who go outside, how to address that, how to make that as least bad as possible?
Yeah, so you don't want your pets getting a disease. Now, luckily, I've been around vets my whole professional career, and pets are not wimps. Humans are wimps, right? Dogs get Lyme disease and you don't even know it. So a lot of times they're not even treated because there's no signs or symptoms associated with it. Sometimes dogs will get the disease and have arthritis and they'll be treated. Importantly, if you don't want your animals to get bit by a tick, it's to use those anti-tick or flea medications, the fipronil, some of the collars that they can wear. Checking tick checks are also important for your animals. Once a tick is attached to your animal, they're going to detach when they're fed. So they're not going to detach and then feed on you until they molt again. Not like a mosquito that'll feed, come back and feed on you.
Right.
Ticks need to get through that developmental stage. So there's not no risk because a tick can fall off after not being attached, but it's doing that tick check, using those anti-tick measures that are really important, and just looking for signs of Lyme disease if there are symptoms that your animal shows, and mainly dogs. Cats don't really show symptoms for Lyme disease often. So
interesting, and probably tougher to do, right? A tick check on a dog, say, than on a toddler, just because one has considerably more hair to hide it, right?
Right, but we all care about our pets, so we'll take our time.
Fair enough. All right, so just because it came up a few times about the just skin color, right? Making it tougher. Are there other? I know, Brian, you touched on demographic differences, gender, age, race. Anything else you want to say in that? Just because we had a few questions come in about that.
Please. You have to realize ticks don't differentiate. They don't care what they're on, right? They don't care the color of your skin, what language you speak, what religion you practice or don't practice. They're there just to feed. And the bacteria itself doesn't differentiate, right? So everybody's at risk. It's something that we're all at risk for. Unless you live in a parking lot and never leave that parking lot or never leave your house, you're at risk. And it's important. Again, I think prevention and knowledge is key, both for individuals and then also for the medical community to know that this is a risk that everybody needs to take into account. There are some differences in who gets it, likely due to behavior, likely due to other factors. But I tell people, look, it doesn't matter what you look like. A tick doesn't care. They're going to bite you and they're going to transmit the disease.
Gotcha. Thank you. And I know we're fairly short on time, but a last question about the vaccine, right? Vaccines have been on our minds, certainly with current events these last couple of years. Perhaps understandable that it's not quite as big an in-your-face thing, that a COVID vaccine received much more attention and money and effort. But what are the factors that drive it, that would lead to it being quicker? Is it funding? Is it, sadly, maybe more people getting it, which drives it to be a higher issue? I'm wondering what you might say about where that lies and in your crystal ball. I know you can't predict everything, but where you would see that going in the coming years.
Well, I can say, so the COVID vaccine, that was an anomaly, and that is largely driven by funding, political pressure, and the sheer numbers of people that were affected by this, right? This was a national crisis and everything came together and they moved all obstacles from all fronts to make this happen. And quite frankly, the profit potential is there for Pfizer, Moderna, all of the developing companies. Unfortunately, because of the debacle, 10, 20 years ago with the Lyme vaccine, no company wanted to touch it. And so there was a lack of a profit incentive. So I think it's just a different situation. And I don't think that's going to be the case with the Lyme disease. It's very slow to develop. And all of the other, as Brian said, remember, even when we get a Lyme vaccine, it's only for Lyme. There are a ton of other co-infections and several of them are here or coming this way. So we need to be thinking beyond just Lyme, and we're not going to be able to get a vaccine for every single co-infection. So that's why we think prevention is so important.
I want to reiterate that the fact that the vaccine for COVID was an anomaly, right? There's a lot of vaccines under development and many of them don't even get to trials because they don't get past those safety. It's things we don't see as the public. We've seen COVID, like, why can't we do it for everything? It doesn't happen like that. Lyme disease vaccine is actually moving pretty quick for a vaccine. It's showing good potential. It's going through the normal regulatory processes that other vaccines go through. So I wouldn't say it's slow. I would say it's on par with other vaccines and have made it farther than most vaccines, which often fail before they get to this point that the Lyme disease vaccine's at.
Got it. Well, thanks to you both. Brian, Royal, appreciate so much your time. Rita, I'll turn it back to you.
Yes, thank you. And yes, Brian and Royale, thank you. Wow, lots of information to absorb. And Brian Hoke, thank you for the Q&A for us. We are going to be putting this, we have recorded this and the video will be on our website within the next couple of days. And so people should feel free to be able to go back and check on some particular information. I also see there's been some links that are in the chat that we can make available to people as well. So thank you. As I always do, I always have to give my focus pitch because we are a nonprofit and we depend on private donations for our existence. So we would always appreciate it. It's very easy to make a donation on our website. A $10 donation, you can't imagine how important that would be for us. So anybody who's willing to do that, we appreciate it. Other than that, again, thank you so much to our presenters and have a great day.
Thank you.
Bye-bye.